Okay, in this screencast we're going to learn how to solve exponential and logarithmic equations, and here's the rule. If b to the x equals b to the y, then x equals y. So the goal, if you can do it, is to make these bases the same. For example, if I have 3 raised to the x plus 2 equals 81, I can write this as 3 raised to the x plus 2 equals 3 to the 4th, because 81 is 3 to the 4th. So now the bases are the same, and I set the exponents equal to each other. So x plus 2 equals 4, so x equals 2. So what do you do if you can't write both sides as the same base raised to different powers? Well, that's where logarithms come in. And so if we're going to find the exact solution to this algebraically, we're going to take the log of both sides, and it doesn't matter what base, but I'll just use natural log. So I'll say natural log of 7 to the x equals the natural log of 20, and then this x comes around front, and then I divide by the natural log of 7, and that is the exact solution to that problem. Now, it would have worked with common logs or any other base logs, but since our calculators work with common logs and natural logs, those are the two we use most often. So let's do a problem where we will use our calculator, and I'm going to just use natural log here. So the natural log of 3 raised to the 2x minus 1 equals the natural log of 5 raised to the x plus 2, and the 2x minus 1 will come around front, and I get the natural log of 3 there, and the x plus 2 will come around front here, and I have natural log of 5. Now I'm going to distribute the natural log of 3 on this side, so I have 2x natural log of 3 minus 1 times the natural log of 3. Let's distribute the natural log of 5 here, so I have x times natural log of 5 plus 2 natural log of 5. Let's get all of our x terms together on one side. So I'm going to subtract x natural log of 5 and add natural log of 3. Factor out an x. And my final step before I bring in the calculator is to divide by 2 natural log of 3 minus natural log of 5. Okay, so now we're ready to calculate this. And I'm going to go parentheses, natural log of 3 plus 2 natural log of 5, close parentheses for the numerator, divided by parentheses for the denominator, 2 natural log of 3 minus natural log of 5, close off the denominator with parentheses, enter, and that's our answer, 7.345. And it asked for it to the nearest thousandth, so that's what I would use, 7.345. Okay, so all of those examples used were exponential equations. Now we're going to solve logarithmic equations. And for this one, remember the base of a common log is 10. So I'm going to convert this to exponential form, and I get 10 to the third equals 9x plus 1. So 1,000 equals 9x plus 1. So 999 equals 9x. So 111 equals x. On this example, the first thing we have to do is condense these two logs into one. And remember, when we add logs, we multiply the terms we're taking the log of. So this is going to be the log of x times x plus 15 equals 2. Now I can convert to exponential form. So this is a base 10 log. 10 squared equals x squared plus 15x, or 100 equals x squared plus 15x, 0 equals x squared plus 15x minus 100, which factors? I think we'll use 5 and 20, and I want to get a plus 15, so I'll do plus 20 minus 5, so x equals negative 20 or 5. Now, recall that we cannot take the log of a negative number, and so that's going to eliminate negative 20. So our only answer for this solution is 5. And our last example involves natural logs. So let's condense these two into one. So I'm going to get the natural log of 2x plus 2 times x minus 2 equals the natural log of 3x plus 8. Now I have one log over here and one log over here, so I just drop it. So 3x plus 8 equals, and I'm going to do FOIL on this, I'm going to get 2x squared minus 4x plus 2x is minus 2x, and then times 2 plus 2 times negative 2, which is minus 4. Getting everything over on one side, that's 2x squared minus 5x minus 12. And let's see if we can factor that. I think we can. We'll put an x and an x. And how about minus 4, which will give us a negative 8x, plus 3x is negative 5x, and then 3 times negative 4 is negative 12. So that works. Okay, so x equals negative 3/2. I get that from setting this factor equal to 0. And x equals 4. Once again, we can't take the log of a negative number, so we toss that one out, and our answer is 4.